So we have this wave function psi of x, and we have the exponential constant is given by this k equals square root of 2m u sub 0 minus e over h bar. And let's see what happens when we when we try and find what the second derivative of psi of x in respect to x is going to give us. That's going to be the second derivative with respect to x of ce to the kx plus de to the minus kx, which is going to equal ck squared e to the kx plus d minus k squared e to the minus kx. And this is the same as ck squared e to the kx plus d k squared e to the minus kx, or k squared ce to the kx plus de to the minus kx. And this is the same as k squared psi of x. And recall that if k equals square root of 2m u0 minus e over h bar, then k squared is going to equal 2m u0 minus e over h bar squared, which means that this psi of x satisfies the time-independent Schrodinger's equation, which means psi of x is a solution. And now we're asked what happens when u0 goes to infinity. So as u0 approaches infinity, k will always also approach infinity. So in the region where x is less than 0, that means that psi of x would equal ce to the kx and minus infinity when k goes to infinity, plus de to the minus infinity, which will go to 0. So psi of x would equal ce to the kx and this is just assuming that u of 0 goes to infinity, so the initial potential is infinite.